Hello and welcome to my channel. In this math video tutorial, I want to discuss partial fractions. When we think about partial fractions, what exactly is partial fraction? Before we define partial fraction, I want to re-establish the concept of fraction. In your basic school or in your basic maths, you were introduced to fractions. What did they say fraction is? Fraction is a part of a whole number or part of a set. So when we have 1/2, this is addressed as a fraction. So in that case, the general form of it is expressed as a/b, where a is the numerator and b is the denominator. So this is the way fraction is expressed, numerator dividing a denominator. And apart from that, we have properties of fraction where you talk about the addition of fraction, subtraction, division, and multiplication of fraction. My major concern is the types of fraction. We have what we call the proper fraction. And proper fraction is when the numerator is lesser than the denominator. So we have, for example, 7/11. 7 is the numerator and 11 is the denominator. 7 is lesser than. So because 11 can comfortably carry 7, this is called proper fraction. So the reverse is the case. If we have 5/2, we observe that the numerator is greater than the denominator, and this is called improper fraction. And in that case, we always convert from improper fraction to mixed fraction, and from mixed fraction back to improper fraction. So having understood this basic concept, what is then partial fraction? By definition, partial fraction is a method of expressing algebraic fraction as the sum of two or more simpler fractions according to certain rule. That is to say, when I have a fraction like, say, 5x plus 3 over x squared minus 4, the idea is to break this proper or this fraction, which is proper. How do I know this is proper? Because the degree of this x is 2 on the denominator and the degree of this x is 1 on the numerator. You observe that this one that is 2 is greater than this, and this makes it a proper fraction. So the idea is to break this down into simpler fractions, such that we have something like this: a over x minus 2 plus a or b over x plus 2. Alright, you may not have idea about whatever it is that happens here, but in the next video I'm going to solve some problems to demonstrate this and explain them in details. So we'll break it down, and then we have the denominator to be some sort of a linear factors. So, but then that's what we call rational function. A rational function is a function of the form q of x equals f of x over g of x. Don't worry if you don't understand all of this. I want to use it to explain some concepts. So in this case, we have g of x not equal to 0. So when we have a rational function of this form, notice or take note that g of x cannot be 0. And then that will mean that f of x and g of x will be a polynomial. So let me explain this in more details. The rational function of f of x over g of x is said to be proper if the degree of f of x is less than the degree of g of x. For example, I think we just explained this when I was introducing the concept of fraction. If I have x minus 3 over x squared minus 5, you can see the degree of x on the denominator is greater than that of the numerator, or the numerator degree is lesser than that of the numerator. If some of the things I'm saying are useful to you, you could also pen them down to make a lot of sense to you. Again, it is said to be improper. It is said to be improper fraction if the degree of the denominator g of x is greater than or equal to the degree of g of x. That's when it is improper. If the degree of f of x rather is greater than or equal to the degree of g of x. So that's when it is called an improper fraction. Just like when I made reference that when you have 5/3, that is, this 5 is greater than or equal to this 3, that's when it is called an improper fraction. Partial fraction can only be used on rational functions where the denominator has a larger degree than the denominator. In the case where the degree of the numerator is larger than the degree of the denominator, what do we do? If we have, say, x squared minus 7 all over x plus 3, when the degree of the numerator is greater than that of the denominator, what do we do? We first use what we call the long division to create a fraction that we can use partial fractions on. Alright? We will solve some problems to demonstrate this. The idea of partial fraction is to undo the operation of combining fractions over a common denominator. So the steps we involve in is we start by checking that the degree of the numerator is strictly less than the degree of the denominator. So when we observe that the degree of the numerator is less than that of the denominator, in most problems this is already the case. If it is not, you will have to use polynomial long division and do partial fraction on the remainder term instead. So what I mean is that whenever we notice that in most cases it's always like this, the numerator is lesser than denominator, so you resolve it to partial fraction. But in some case where you have the numerator greater than the denominator, what we need to do is to use long division method. And the reasons for which we do that is to get the remainder and then eventually evaluate the partial fraction. So that is essentially the basics of partial fraction. And in subsequent video, I want to solve a lot of problems. So if you've not subscribed to my YouTube channel, consider hitting the subscribe button and don't forget to turn on the notification bell. The essence of doing that is by the time I upload new video, you get notified. And again, if you found this video helpful, consider liking the video and please share. Thank you very much and stay tuned.